quantum computing could allow us to think more relationally and beyond dualism. But the way it's currently being used by big tech and the military is very much in the sort of Western, Cartesian, dualist framework.
Welcome to Art is Not a Thing, the podcast series about art as a practice of critical inquiry, knowledge production, and world building. My name is Anna Carabella, and on this podcast I talk to artists and researchers whose work questions and reimagines our practices in and of the world. In this episode, I'm joined by artist Libby Healy. Rather than using quantum theory as metaphor or for speculative world building, Libby engages quantum processes as active constraints that undo linear causality, hierarchical relations, and the bounded subject. Drawing on her PhD in quantum information science, she works with phenomena such as superposition, entanglement, and non-locality to explore what happens when perception does not fully stabilize, when time does not resolve into sequence, and when experience resists narrative closure. In today's episode, we talk about how quantum logic makes its way into art, society, and politics. Welcome, Libby. Thank you so much for joining me today. It's great to have you on this podcast.
How's it going?
Good. I'm excited to talk to you about this.
Yes.
So, the United Nations General Assembly declared 2025 as the International Year of Quantum Science and Technology. And even though this has brought more visibility to the field, I feel like to most of us, quantum remains opaque, inaccessible, kind of intimidating, I guess. And perhaps I thought it would be good to start with asking you to explain a few key concepts in quantum that are also relevant for your artistic practice.
So, well, first of all, thank you for having me on the podcast. It's super great to be here. Quantum is, entirely different to how we as human beings experience reality through our senses and through any of our tools. So it's not more of the same. So some of the key things that we learn when as a scientist, I learned when I studied quantum physics as an undergraduate are things like superposition, which I use in my work as well, because it's really one of the key phenomena that is different to classical or macroscopic phenomena. So for instance, superposition is when one entity, like an atom or a molecule or a subatomic particle, can exist in more than one state simultaneously. So this is like a material object, so it's made of matter, or it could be a photon, which is light, a particle of pure energy, but it's really doing two or more contradictory things at once. So a good example is an atom can be in two places at once, left and right, or it could be spinning up and down at the same time. You know, if we try to imagine like a football and it's spinning up and down at once, we're like, no, that can't happen. But in the quantum world, it does. And then entanglement. And I think in the art world, we use the word entanglement to mean deep connection. And obviously that's true as well, but that's still a classical interpretation or meaning of that word. In quantum physics, it's really has quite a strict, obviously it's science, a strict definition. So quantum in sort of words, quantum entanglement, where you have two or more entities, so atoms, molecules, etc., objects that behave by the laws of quantum mechanics, and they become connected in such a deep way that it's no longer possible to tell an individual entity, tell them apart. But one thing that I think gets missed in a lot of the artistic sort of discussions around entanglement and the difference between like using it kind of to mean, like there's that book Entangled Life, which is a wonderful book by Merlin Sheldrake, but he's still working very much in the classical non-quantum regime, whereas in quantum physics, you have you have a superposition principle, so all possible ways of connecting exist at the same time. So you end up with this sort of layered layered reality, or like I use the word multiverse to describe these things.
Very good crash course in quantum. So now that we have that, and as you were saying, quantum is often described as revealing reality in ways that we don't encounter it in everyday life, or in ways that we don't perceive it necessarily. And I was wondering, beyond functioning as a tool for explanation or translation, what kinds of experiences or forms of understanding can art open up in relation to quantum phenomena? And how do you actually do that in your practice?
Yeah, so we can use tools. I say we, I mean artists can use tools like quantum computing, or there's lots of other quantum technologies. Um, Obviously, at the moment, they're not widely available. You have to sort of collaborate with a tech company or an academic, so there's problematics around that. But I guess that's for another
Mm.
conversation. But and when you do this, you can start to access the physics of the quantum world, but there's always this process of translation back to the classical world, the macroscopic world. Um, but then you start to see and hear or experience reality as multiple and deeply interconnected if you use these tools in a particular way. Because sometimes you can use quantum computing, for instance, to currently to kind of just generate kind of what I would call like digital art. So you're not really seeing anything new. So you really have to look at these phenomena that I just described to kind of glean or generate a new aesthetic. And I've been doing this in my work, I think, no, since 2019, really working with entanglement, superposition, coherence, interferences to show the layered, multiple nature of reality. And that comes across in different video works like U is for Climate, Slime Crawl, and I just opened a show in Norwich like a week ago. That's called Life in the Multiverse, and I think that audiences can, if you see a still image of my work, it looks kind of blurry and abstract. It's like it doesn't seem like there's anything meaningful there. But because I'm working with layered videos or what else do I do? Like simulation in real time, in Unity, for instance, or sound. When you're actually in the space and experience it through time, and you experience the non-linear temporalities and the shifts and the instability, you get a sense of through your body and through feeling and emotion, you get a sense of what all of this is about. But I think the structures of the quantum world are so beyond, or not so beyond, but can quite often be beyond classical binary forms or digital forms of cognition. So, like, our brain is not capable of understanding certain quantum structures visually, for instance, because we've never encountered them before. Yeah.
Libby is an award-winning artist with a professional background in quantum science. She is the first artist to work with quantum computing as a functioning artistic medium. Libby's practice explores quantum concepts and temporalities, combining diverse media such as moving image, glass, and watercolor with cutting-edge technologies. In doing so, she seeks to entangle interior landscapes with the impact of the exterior realm, asking big philosophical questions while remaining intimate, human, and embodied. Libby holds a PhD in quantum information science and worked as a postdoctoral researcher in quantum science at the University of Oxford and the National University of Singapore. She also holds an MA in art and science from Central St. Martin's in London. On to the next question. In recent times, there's been a shift away from Cartesian distinctions that privilege rational thought over embodied and sensory knowledge. However, this binary logic has been taken up by digital computation models, and so it continues to have a hold on how we understand the world. Now, quantum physics and by extension quantum computing kind of goes against that and supports this departure from the binary distinctions towards more relational, indeterminate ways of knowing and inhabiting the world. Perhaps you could tell us also now how you understand the difference between quantum computing and digital computing as maybe two different epistemological frameworks. How does quantum computing challenge current ways of sense making?
Yeah, I mean, this is a really good question, of course. First of all, I'll say that quantum computing could, like, allow us to think more relationally and plural and beyond sort of duality, dualism. But the way it's currently being used by big tech and the military is very much in the sort of Western Cartesian dualist framework. And that's so important to know because, like, if artists or if certain, say, indigenous groups were working with quantum, then I'm sure they would really use it, not to solve a problem and have one true answer and everything else is false, but they would allow themselves to sit with that multiplicity and not resolve it. Whereas big tech and is a non-binary technology inside the quantum computer, but the output is always binary. It's always true or false. So in my work, for instance, I'm not resolving. I never resolve. I allow all the possibilities to exist simultaneously, and so it's really showing what it could be. So yeah, in terms of your question, I just really wanted to clarify that because quantum computing, I'm very critical of
Yeah.
it, even though I propose alternatives in my work. What it could be if it was used by different groups of people. Um, but in terms like digital computing and its logics are based upon the binary. They're based upon zeros and ones, based upon linearity, based upon copies. So digital computation is highly bound up with capitalism and colonialism and so on. Quantum computing utilizes superposition and entanglement and some other quantum phenomena. And it really does sample all. It's not that it's quickly sampling one option and then the other option and deciding which one is better. It really is doing everything at once in a way. I mean, it's a bit more complicated than this, but it's almost like it samples everything at once, just on one set of bits. So all of those bits are doing quantum bits and not digital bits. Are doing everything at once, and then but scientists sort of resolve or make real one possible outcome. Let's imagine that we could use quantum in a truly non-binary way, unlike, so we're not trying to solve a problem. Like, I think quantum computing could really help us reimagine computation altogether, because to compute something means to solve something. You're looking for an answer, but what happens if there was no answer? What happens if there is no truth? So yeah, then you really move into this sort of fully relational, but not relational in the way that artists usually use that word. It's more radical. You have all possible relations existing at once, not just like, oh, there's a network of relations, but it's all networks of relations. And they're all equally valid without hierarchy as well. They're horizontal. And it's not like I mentioned earlier, there are no in a quantum system when there's entanglement, there are no individuals as well. Like, it's if you try to gain an individual, you destroy the system. It's not like, oh yeah, if we look in a certain way, we can get an individual. No, no, no. Actually, you can't. Um, so I think it really connects to other knowledges, indigenous knowledges. I was having a conversation yesterday with one of my yoga teachers who was talking about tantra philosophy and yoga, and we were saying how similar it is to quantum physics, and just how the West seems to be catching up with a lot of these old knowledges that we intuited through our bodies. It's not to say they're identical, but it's just other ways of understanding the world.
Yeah, great. I think you said a couple of things that kind of, popped up in me thinking and also like relating to the next question, which is I guess it's kind of safe to say that different epistemological frameworks will kind of inevitably lead to new political or social paradigms. And you've already mentioned a couple of things like the, you know, can't like catch the individual or and a few other things there that um, kind of led me to think of this, like what you think the political implications and the political potential of, you know, having quantum logics more present into our everyday life can be.
Yeah, again, I really want to caveat this question because I mean, you know this. I talk about the double edge of quantum computing. On one hand, you have this physics that underlies it, which is really radical and queer and really leads to
Yeah.
these new epistemological frameworks. But then on the other hand, like we should also say full scale error corrected quantum computers do not exist yet. There's a big sort of, they call it, I mean, I say they, people like MIT Press or I think New York Times call it the quantum arms race between different tech companies and different
Mhm.
geopolitical areas of the world. They're trying to create quantum computers because they are capable of cracking all known encryption. They're capable of doing things like unindexed search, which is incredibly powerful search, like way beyond. And they also run certain problems, simulation problems, where all of these, no digital computer, even if it was as big as the planet Earth, could ever solve these problems. And quantum computers can do this. One might already exist. The US military or the Chinese military might already have them. They won't tell us about them. So I feel like you know, there's a hopeful side from the like underlying phenomena, but these this quantum physics, which is magical, it is so beyond us and leads to these new sort of post-individual ways of thinking, also that are connected to old ways of thinking. But then on the other hand, we have this really terrifying prospect of quantum technologies just extending and expanding the current status quo, and that is the way it's going at the moment. So it's really this double edge thing. And my artwork Ent, which is 4 years old now, really looked into this in a very visual and emotional, um, embodied way. But I think, like, you know, if for instance we artists and other groups that were more inclined to think about things like without the individual were to work with these technologies, then you know we could really reimagine. I always think like quantum time is nonlinear, circular, where you've got all of these different intersecting timelines happening at once as a result of superposition. And then you don't need to, like, optimize for one, you know, the economy or for, certain countries. It's like they're all allowed to exist and blend and merge. And you have something in the quantum realm called no cloning theorem. That just basically means you can't copy. Um, any quantum state that's in a superposition or entanglement, it's impossible to make copies of it. And this underpins quantum cryptography. You can't like if someone's got an encrypted quantum channel, it's impossible to copy the information out of that channel. So you prevent eavesdropping, and that's actually already in use. People. Um, Governments, for instance, and the military are already using this. That's like developed. But also, you know, in art, we often talk about copies. It underpins postmodernism and, you know, copies of copies, simulation and simulacra, all of these things. But imagine a world without copying, you know, in terms of production, all sorts of different things. Accountancy, AI is completely different if you can't copy data. So, you know, artists and designers and creators of all different people, like all different types of people, should like think about. Should I invite them to think about these questions because I think it's so interesting to imagine like these other realities where things that we take for granted, like copying, just can't exist. What is left? Our brains don't. Human consciousness isn't even a thing then. there's something else entirely, and that's interesting.
That's super interesting. I wanted to end on a positive note, but thank you for that. I just as a final thought, because you did mention like the challenges artists face when working with quantum because it's not yet available, and then you have to rely on either
Mm.
academic or corporate structures to have access to it. Which I think this idea ties into the question about politics and the potential as opposed to the reality that you were describing, perhaps. And I wanted to
Mm.
ask you also, how do you navigate that tension in your artistic practice, the tension between wanting to do things differently and then still having to work within a structure, either corporate or academic, that might be using quantum very differently from how you would want to use it in your work?
I mean, yeah, it's a thing, isn't it? And I guess anyone working with tech of all different types has to
Yeah.
confront this because, AI is not neutral. Even if you build your own model, it is still or no technology is neutral. And I feel
Yeah.
like for me, so I don't collaborate or I haven't collaborated with a big tech company. I've always worked independently because I know I'm very fortunate that I know how to program certain things on the machine, so I can write my own code and do what I want to do, rather than use any software or have a formal relationship. But it does make access difficult sometimes, and I do have to rely on, like, connections and networks. There are some publicly available options, but you don't get enough time to really do anything meaningful that would look visually meaningful. Um, but in terms of, like, the actual politics of working with these tools, I mean, one thing that quantum teaches us is how to sit with paradox. Like, it is a paradoxical theory. If you think of Schrodinger's cat, it's dead and alive, that's paradoxical, right? So I embrace that, and I can't, as an individual artist, I can't sort of say, "Oh, yeah, I'm outside the system. I'm not I'm resisting quantum." I'm not. But also, in a way, by having these conversations and by making work that looks at alternatives, I hope that the little strand of a branch of quantum I occupy offers hope and, alternatives compared to what else there is out there. So yeah, it is as it is.
Yeah, I guess that's the struggle of any artist that works with technology these days. Thank you so much for joining me, Libby. It's been an absolute pleasure to have you, and hopefully we've cleared up some questions around quantum for our listeners.
Yeah, it's been a pleasure to speak to you as well, Anna. Thank you so much for having me.
That's it for today. Thank you so much for tuning in and hope you enjoyed it. Join us next month for a new episode, and in the meantime, follow us or share the show with someone you think might like it.